Close your eyes for a moment and imagine this. Above our heads, in the silence of space, thousands of satellites race around Earth at a speed faster than a rifle bullet. They are delivering internet, guiding airplanes, predicting tomorrow's weather, and even helping you navigate to your favorite cafe. Now picture two of these satellites, each worth millions of dollars, accidentally heading straight toward one another. There are no brakes in space, no stop signs, no traffic lights, just physics. If they collide, the explosion could shatter them into tens of thousands of pieces, turning a small accident into a deadly chain reaction that could threaten every other satellite in orbit. So how do satellites actually avoid hitting each other in the crowded, invisible highway around Earth? That's the story we are diving into today. You might wonder, if satellites flying blind with no windows, how do they even know where the others are? Well, the truth is, satellites don't see each other, we see them for them. On Earth, powerful radars and telescopes, operated by different organizations, scan the skies every second. They track more than 30,000 objects from active satellites to old rocket parts, building a massive space catalog. Think of it as an air traffic control system for space. But satellites also help themselves. Many modern ones carry onboard navigation system, a bit like GPS, that tell them exactly where they are and where they are going. Finally, the math does the magic. Engineers feed all this data into prediction software, running orbital mechanic equations, Kepler's law, gravity effects, even the drag of thin upper atmosphere. If satellites A and B are predicted to pass within just 1 kilometer of each other, an alert is issued. So what happens when the warming comes in? This is when a satellite performs a collision-avoidance maneuver or CAM. It doesn't need a dramatic rocket burn or a huge course change. Often, a tiny push from small onboard thrusters, just a few centimeters per second of velocity change, is enough to shift its path. That little nudge means that hours later the satellite will pass safely kilometers away from danger. In 2020, the European Space Agency had to do exactly this. One of their satellites was predicted to come dangerously close to the SpaceX Starlink satellite. A careful maneuver saved both. But here's the catch: fuel is precious. Every time a satellite dodges, it spends some of its limited propellant, and once the tank is empty, the satellite can no longer maneuver, so engineers must plan each move wisely. Keeping satellites safe isn't as easy as just dodging every time. There are real challenges: fuel limits. Satellite can't dodge endlessly, so engineers design a fuel budget for the entire mission. Communication delays. Sometimes there are only hours to make a decision. Operators on Earth must act fast. Automation. Companies like SpaceX have introduced autonomous collision avoidance, satellites that move on their own without waiting for ground control. Coordination. With thousands of satellites owned by different countries and companies, there is no single global referee. Sharing data is crucial, but politics can make that complicated. It's like having thousands of cars on a highway, but each car belongs to a different country, and they don't always agree on the rules. So what happens if the satellites don't move? Here's the nightmare scenario: Kessler syndrome. In 2009, an old Russian satellite smashed into a working US radio communication satellite. The collision created over 2,000 new pieces of debris, each one a potential bullet in an orbit. Kessler syndrome warns us that one crash can trigger another and another until Earth is surrounded by a deadly cloud of junk. If that happens, launching new satellites or even traveling to space could become impossible for decades. Avoidance then isn't just smart, it's survival. The good news, engineers aren't giving up. The future of collision avoidance looks like this: International Space Traffic Management, a global air traffic control system for satellite, better tracking systems using AI, lasers, and advanced radar to predict close calls more accurately. Autonomous satellites, self-driving satellites that automatically dodge obstacles without waiting for humans. Active debris removal, imagine space garbage trucks capturing old satellites or dragging them into Earth's atmosphere to burn up. It's not science fiction, prototyping are already being tested. The next time you check the weather, use GPS, or watch a satellite image of a hurricane, someone above, engineers and algorithms are constantly working to keep those satellites safe, quietly dodging potential disaster we never see. Because every avoided collision is more than just saving a machine. It's protecting the delicate web of technology that modern life depends on. And here's the bigger picture. As we launch tens of thousands of new satellites in the coming decades, space traffic control will become one of the most important jobs humanity has ever created. If we succeed, the sky above us will remain a safe highway of innovation. If we fail, the space around Earth could turn into a minefield that locks us on this planet for generations. So the real story of satellite avoiding collisions isn't just clever engineering, it's about securing our future in space itself. Don't miss out, new videos drop every Sunday evening. Hit subscribe and ring the bell so you are the first to watch.